We want to find the electric potential at the center of this semicircle. The rod has a total charge of negative 6.5 microcoulombs. All right, so let's just write down the givens here. The total charge is going to be negative 6.5 microcoulombs. We see that the arc length of our rod is 0.14 meters. S is commonly used to represent the length of curves. And at first it might seem like this might be a tough one to answer because of the geometry of it. But one thing we know is if all these negative particles are spread out uniformly among the rod, then what we'll find is that they actually all have the same distance to center, and that's critical to solving this question. Because what is potential really based on, right? It's based on the amount of charge, which we have, and the amount of distance between those charges and the point where we're evaluating the potential. So interestingly, this one can be solved if we just use the total charge and the distance that all of those charges are from center. They're all the same distance from point O. So we just have to find out what that distance is. One formula we can use from Physics 1 would be S equals R theta. We know the distance of the arc. We want to find the radius. And for the theta, we'll actually use 180 degrees, but it has to be in radians for this formula to work. So now we can just divide by pi, find the radius. All right, so we're going to get 9e to the 9. Negative 6.5 microcoulombs and 0.14 meters over pi for our distance. I'm getting a potential of negative 1,313,000 volts.